Hello everyone. My name is Ruturaj Ramdasikam, and today I will be presenting on the topic self-attention mechanism as a part of our deep learning IC evolution tool. In this presentation, I will explain what self-attention is, why it is important, how it works, and where it is used, especially in text and time series applications. So let's start with the introduction. Why do we need self-attention mechanism? Traditional models like recurrent neural networks, convolutional neural networks have difficulty in capturing long-term dependencies in data. Recurrent neural networks process information sequentially, making them slow and memory limited. The self-attention mechanism solves this problem by allowing the model to focus on the most relevant parts of the same sequence. It helps the network understand relationship between words even if they are apart from each other. It also enables parallel computation, which speeds up training and improves context understanding. For example, in the sentence, the dog that chased the cat was fast. The word dog is currently linked with was fast using self-attention mechanism. Thank you. So now let's understand what self-attention actually is. Self-attention is a mechanism where each token or word is a sequence of attendance to all other tokens to learn their relationships. It creates richer, more meaningful representation for every word. This concept was first introduced in 2017 by Vaishnavi, ETA. In the research paper, Attention is All You Need. It forms the foundation of the modern architectures like transformers, BERT, and GPT. The self-attention process mainly works with three components: query, key, and value vectors. Each word's query is compared with very other word's key to calculate how much attention it should receive. So now let's see self-attention mechanisms applications in NLP. Let's see some key applications. Machine translation, converting text from one language to another. For example, English to Marathi. Text summarization, extracting key information from long documents, creating short summaries. Questions answering systems, understanding a passage and giving a precise answer like chatbots or search engines. Sentiment analysis, detecting positive or the negative opinions in social media posts or reviews. Name entity recognitions, identifying names of people, places, or organizations in a sentence. Example, in YouTube comment analysis, self-attention helps detect whether a comment shows satisfaction of or criticism about a particular YouTube user. So now, apart from the text, let's see self-attention is very useful for time-dependent data such as the financial or the sensor readings. Here are some examples. Stock market prediction, forecasting future stock prices by learning complex temporal dependencies. Weather forecasting, predicting rainfall, temperature, or humidity based on the past readings. Health monitor, detecting anomalies in ECG or the heart rate data collected over time, etc. Now, self-attention can look at both recent and the distant time points to make accurate long-term applications. Anomaly detection, identifying abnormal activities in data such as network institutions or machine faults. Now let's understand how the self-attention mechanisms actually works. The process includes few main steps. Each input word is first converted into an embedded vector. From each input, three vectors are generated. Query is denoted as capital Q, key is denoted as K, and value is denoted as V. The attention score is computed by taking the dot product of query and the key, then dividing by the square root of their dimensions. These scores are normalized using a softmax function. The normalized weights are multiplied with the value vectors to produce the final output. In transformers, multiple attention heads are used. This is called as multi-head attention capture different types of the relationships. In short, input is given to the queue, query, key, and value is given to the attention scores, is calculated the weighted sum, and then we get the output. Now let's see. Self-attention is very powerful. It is also has a few challenges. It has high computational cost. The attention matrix grows quadrically with sequence length. It needs positional encoding to remember the order of words. Attention weights can be hard to interpret, making model behavior difficult to explain. It may also overfit small datasets because of its high learning capacity. These are the reasons why optimization in self-attention for long sequences still is an active research area. Now summarize the whole our presentation. To summarize, self-attention also allows each word in a sentence to understand its relationship with all other words. It is the core mechanism of transformer which have replaced recurrent neural networks in most modern AI applications. It provides faster training, parallel processing, and better contextual awareness. Even though it is computationally heavy, self-attention has revolutionized deep learning and natural language processing forming the base of the models like BERT, ChatGPT, and T5. Thank you for listening.